Hey everyone, this is Dr. Walker. This is video 542 on resistivity. Resistivity is a very important property of materials that tell us how they resist the flow of current. But before we can talk about it, we have to consider conductivity first. So imagine we have a conductor and there's a potential difference set up between the ends. We know that when we have that potential difference, we know that we have an electric field that is established, and we also have a current density where we have a flow of current through that conductor going through that area. So the current density is actually proportional to the electric field that is set up. And the constant of proportionality is called the conductivity, sigma. Sigma is a measure of a material's ability to conduct electricity. The higher the conductivity, then the higher current density is established in that conductor. The units are ohms. We haven't seen this before, OHM. We're going to see it later. It's the unit for resistance. So ohms meters to the -1. Now that we understand conductivity, we can define resistivity, which is the reciprocal of conductivity. So 1 over sigma is our resistivity. Resistivity measures how strongly a material opposes the flow of current. So a material that has a high conductivity that allows that current to flow is going to have a low resistivity, and vice versa. The unit for resistivity is ohm times meter. So the resistivity is a property of the material, and we're usually given the property. We're usually given that resistivity. The resistivity is affected by the temperature, and it varies approximately linearly with temperature. We are given this relationship here that tells us that if we have an initial temperature T0, which is usually 20 degrees Celsius, and we have a change in temperature, a delta T here, then whatever our initial resistivity is, it's going to increase to a new resistivity rho. And alpha is a temperature coefficient of resistivity, which is also a constant that depends on the material, and it is usually given to us. What this equation tells us is that in most conducting metals, the resistivity does increase with temperature because as delta T is positive, then our rho is going to get bigger. A notable exception to this would be in semiconductors, which are essential components of your electronic circuits. In those, we actually have the resistivity actually decreases when you increase the temperature. Let's look at one question. When does an incandescent light bulb carry more current? Is it immediately after it is turned on, when the glow of the metal filament is increasing, or after it has been on for a few milliseconds and the glow is steady? So think about it, pause the video if you'd like. So we said that resistivity usually increases with temperature. So if we want a high current, we want a low resistivity because remember, resistivity is how much you oppose current. High resistivity means you oppose current a lot. So we want a low resistivity to have a lot of current. We have a low resistivity when we're cooler because resistivity increases with temperature. So for which of these cases is the metal cooler? Well, it's going to be immediately after it is turned on, because after a while it's going to glow a lot hotter. So the answer is A, that we have a lower resistivity at a lower temperature, and that's what is going to allow more current. And this is actually why in some old light bulbs sometimes they blow as soon as you turn them on, because you have that surge of current that the filament just cannot handle.